Well, welcome everyone. Thanks for joining us in person and online, for our folks online, for the third of a series of 4 textile talks that started late last year. These sessions are presented by our Fibre platform and Kite Creates, and my name is Helen Weston, and I'm part of the Kite Creates and the Fibre team. If this is your first event with us, thanks for finding us and joining us. And if you haven't already, help yourselves to tea and coffee. And stay with us for the networking time at the end of the talk. For those that are new, a little bit about what Fibre and Kite Creates does. So Fibre is an academic research platform in the field of textile-based wearable technologies and adaptive fashion, operating here at the Kite Research Institute. Its mission is to make care accessible to people through technology by designing and integrating smart textiles across the healthcare system. Kite Creates builds bridges between innovators in healthcare and creative industries, with the aim to merge these with scientific expertise and create human-centered design solutions for complex accessibility needs. I'm delighted to introduce our speaker, who will be taking us through our topic today. So Dr. Saiful Hoque is a textile engineer and materials researcher whose work bridges fibre and polymer science, textile manufacturing, sustainability, and smart technologies. His research focuses on material performance, degradation, and the development of textile-based sensors and actuators for healthcare and rehabilitation. So currently, Saiful is a postdoctoral fellow at the University of Toronto's Institute of Biomedical Engineering and here at Kite. In addition to his research, Saiful serves as Vice President of the Institute of Textile Science, ITS Canada, where he supports knowledge exchange and innovation within the textile community. So I'd like to welcome Saiful.
Thank you so much, Helen, for the nice introduction, and my huge thanks to all of you for being here today. The weather is terrible outside, and I really appreciate that you are investing this time to be here. Hopefully, we'll have some time after the talk as well to talk and know each other, and I'll be happy to answer if you have any questions apart from the presentation, but relevant to textiles and the work I'm doing right now. As always, I would like to start the presentation by acknowledging the land Kite Toronto Rehabilitation Institute and University Health Network operates. For thousands of years, it has been the traditional land of Huron-Wendat, the Seneca, and the Mississaugas of Credit. Today, the meeting place is still the home to many indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. As I start, I would like to mention about what could be the session outcome. As we are talking about textile coloration, I hope you will have some understanding about textile coloration by the end of this session. Also, I'm going to explain about textile dyeing a little bit, so I hope you'll be able to explain textile dyeing. And you will be able to recognize some sustainable alternatives for textile coloration and functional finishes. Here I have a QR code or the website as uoft.me/textile coloration. I have uploaded some documents, articles for you to have a look. Can anyone check if the QR code is working? Sounds good. Thank you so much. So you will have until tomorrow to download all the materials I have there. So let's start with a very simple questions. Do you like color? There is no right or wrong answer. It could be yes or no. So here, I would like to request you to scan the QR code, or you can go to menti.com and with the code 74997604 to answer the quiz. I will give a few seconds for you to scan the code. Media team, can you please switch the screen and go to the response?
Sorry, Saiful, when you say colorful, do you mean like clothing with a lot of color together, or like clothing with block, like solid color but bright color?
All, apart from black and white, like apart from dull color. If there is any color, doesn't matter if it is a pattern or it is a solid color. I'll give a few seconds. And let's move to the results. So as you can see here, the majority of the people who responded like colorful cloth. And regardless of whether you like color or not, can you move to the presentation? Thank you so much. So regardless of if you like color or not, color actually matters. I would like to start with the left example in the left side of my slide. You'll see an octopus. And the thing the octopus is doing is an adaptive camouflage. So color is not about only aesthetic purpose. It's largely being used now in the industry for the protective purpose as well. For instance, here in the octopus, they are changing their color, also the structure, the shape, to disguise themselves and protect themselves from diverse situation, also to communicate with each other. And getting the inspiration from the nature, on the right side, you see an example of adaptive camouflage garments. And here the research, this is a very interesting article. I will recommend you to go through if you are interested with adaptive camouflage. And this is an example of application of thermochromic dyes or ink. So the thing people did here for the right image, they included several colors. And they saw what is the transition of the color. So the primary design here is with the leaf design. And with the transition, it can move to a desert design. They use different color, and the transition for most of the color they found at between 37 and 39 degrees centigrade. So considering our core body temperature is 37, but skin temperature is below than that. So considering that 37 or 38 might be very high, but two color was found very close to the skin temperature, especially yellow, which got the transition around 31.9 degrees centigrade, and the green also had the transition at 30.7 degrees centigrade. So these are a very cool example of thermochromic dyes or the coloration, and can be applied in protective field as well. Apart from the protective field, color also matters how it represents ourselves. For instance, if we go for a funeral, we go for black. If we go for a job interview or a professional event, we go for blue or some bright color. Also with the culture as well. The picture on the right, you see it represents a culture. Sometimes in wedding ceremony, culture-wise is different, or also with the season-wise. So history also tells the same. People have a long interest to color since the beginning color invented. And according to research, 85% of the product we buy because of color, especially when we talk about the textiles, 85% of the clothes we buy because the color attracts us, apart from fabric construction, apart from fashion as well. So the very first study which has been done on people preference on color was done in 1893. And another study tried to synthesize all the color study together, as you can see in this slide, and how people's preference on color has been changed along the way. So as you see, in most of the cases, beginning from 1893 until today, people used blue as their most preferred color material. And as the less preferred color, they identified, less attractive color, they identified yellow. And things has been changed slowly. For instance, if you see closely, my apologies if the text is very small. If you see closely at the beginning, blue, red, light blue, everything linked with the blue was the more attractive, identified as more attractive. And it has been changed now, is more with blue and purple ink. Also, this color preference has been a motivating factor by culture. For instance, a study was done in mid-90s. They did, this is a very small cohort study. They did that study with 160 male and female Americans, Vietnamese, Kuwaitis, Iranian. And they found that American people prefer red and blue as their highest preferred color. On the other hand, Kuwaitis people marked this red and blue as their lowest preferred color. So it also depends on from which demographic region you are working on. But in most of the cases, most of the studies which has been done with large cohort of people, large cohort of participants, identified blue as their most preferred color. So if anyone is working in the color industry, regardless of textiles, I highly recommend going through this paper. This will give you a very good idea if you want to work with color and what people will be interested to buy. Talking about color, let's move to the textile coloration, the today's topic. And textile coloration can be done in different ways. In most of the fabric we wear today is done by dyeing or printing. Also, there is another way to do the textile coloration is like structural color. The first example I was showing, octopus example, the adaptive camouflage. This is the mechanism of structural color. Also, if you want to talk about structural color, you can see some example here where without using any dyes or pigments, we can just modify the color by modifying the structure of the surface or the substrate upon which we are applying the color. And talking about the textile color, let's start with a very simple definition of dyes and pigments, because these are the most widely used color concept. So a dye is a colorant which is soluble, as you can see on the right side of the video. When she put the dyes, it instantly soluble. But on the other hand, pigments are something which is not soluble in water. So this gives two important properties. For instance, for the dyes, as you can see, it's getting soluble, so it's easy to penetrate on the fabric itself. We do different other, use other auxiliaries to make it good bonding with the fabric, but in a summary, dyes are very good, dyes made very good bonding with the fabric. On the other hand, pigments, as you can see, these are not soluble. While you put that pigment on the fabric as well, it doesn't bond with the fiber. So we use other auxiliaries, for instance, binder or glue or adhesive, in whichever term we say, to fix it on the textile substrate. See, if I link this description with some properties, for instance, while we are buying some cloth, we want to have this cloth lasting for a longer time. And if the fabric is dyed, this has higher chance of having a good color fastness. That means over time, the color will not fade that much compared to a pigmented fabric. On the other hand, as pigments are binded to the fabric with adhesive or binder, only a tiny surface area of the pigment is exposed to light. And I was mentioning this in my previous session as well. Light is a crucial factor to degrade your fabric. So as pigmented are typically large particles, and also the whole pigment is not exposed to the light, you have less chance of light degradation on the pigmented material. So there is always, when you talk about textile, there is always trade-off, but according to the end use we are aiming for, we try to choose which particular product is good for us. And talking about the dyes and pigments, what could be the sources of this dyes and pigment? If I want to classify dyeing or the textile coloration, one classification can be done based on the sources. For instance, the dyes or pigments can be coming from natural sources. As you can see on the left side, the fabrics are from naturally extracted dyeing particle. Also, the synthetic dyes is very popular. In most of the cases, I don't know the number, but in most of the cases, the fabric we are wearing is mostly from synthetic dye. Also, how we are applying the dyeing in the dyeing process also make another category of classification. For instance, if we apply the dye in the dyeing bath in an acidic medium, we call it acidic dye. For instance, again, taking inspiration from natural sources like hibiscus is an example of acid dye. It could be direct dye as well, the way we are applying. For instance, turmeric is an example of direct dye. Also, the classification can be done based on the chemical structure of the dyes or pigments. For example, this is an example of azo dye. So based on the chemical structure, we can mention what type of dyeing it is. However, I would like to mention that there are almost a lot of overlapping with different types of classification. For instance, a natural dye can be an acid dye. In most of the cases, natural dye or acidic dyeing. Also, it can be an azo dye as well. So that there is no confusion on that. So in the next part, I'll be moving more on the application. Before going there, for the initial part, is there any question? I know there is a question time at the end of the session as well, but in the meantime, if there is something urgent you want to discuss, I'd be happy to take. Perfect. So I'll move forward with the simple dyeing process. I'll start with the cotton. Natural fiber is mostly, we had any question, Helen? No, okay, yeah. So I'll start with the cotton dyeing process. And in the beginning, I was mentioning like dyeing, whenever we are talking about dyeing, we want to bond the dye particles with the fiber itself. So the fiber chemistry matters a lot. If you look at the cellulose repeat unit, which you can find in the cotton fiber, you see cellulose has a lot of hydroxyl group. So we want to activate this hydroxyl group. So we include caustic soda, sodium hydroxide, into the dye solution. And for example, if you take one example of dye, this is an example of reactive dye. With the sodium hydroxide, we activate the hydroxyl group, and the hydroxyl group then react with the dye component, and it creates byproduct, it creates hydrochloric acid, and on the other hand, the dye get fixed with the fiber. As the fiber are bonded closely with the dye, the color fastness properties over time is very good while we are dyeing. But in most of the cases, if you look at your fabric, in most of the cases, these are a blend of different fibers. In, I guess, most of the cases, CVC, cheap value of cotton, you will see for this sportswear, you will see a lot of polyester and elastane blend. So for today's session, I wanted to take a difficult example and walk through it regarding how we dye our material. And as a test material, let's consider that we are dyeing a fabric which is a combination of polyester and elastane fiber. Elastane is like the elastic material, and the polyester, you know all, is petroleum based. So if you consider an industrial process and you wanted to dye this fabric, it's not like always as simple as it is. It's not only the reactive dye and you put it in the bath and boom, we have a color fabric. It takes a lot of consideration. It takes a lot of variables to take into consideration to do a fabric perfect dyeing. So we start with taking the water in our dyeing bath. Usually we start with a warm water. For instance, for this case, I will start with 50 degrees centigrade warm water. We'll just fill the water. Sometimes the machine comes with the facility to warm water, or sometimes we have to warm the water in a different bath and take it in our dyeing bath. The question is why we want to start with the warm water. Again, as I said, which material we are dyeing is a big consideration. For instance, when we're talking about polyester and elastane, these are very hydrophobic. And if we want to dye, we want to start with a very low temperature water, cold water, the wetting process takes a lot of time. So for instance, for this case, I'll get the fabric wetting within 10 minutes. If I want to start with a cold water, it will take, for an even wetting, it will take almost an hour if we want to start with the polyester. So that's why we start with a warm temperature, for instance, here 50 degrees centigrade. Then in the warm water, we insert our gray fabric. So here with the gray fabric, I mean the fabric I'm getting from knitting department or the weaving department after the manufacturing of the fabric. So one of the consideration for any fabric which combine elastane or the spandex fiber, the fabric needs to be heat treated. and then we take the fabric. So then we insert the fabric, heat-setted fabric, in 50 degrees centigrade warm temperature. However, as the fabric is coming from another department, like after weaving or after knitting, if you had the chance to see how weaving and knitting works, the machine has a lot of grease, and this grease usually comes to your fabric as well. Apart from the machine grease, from other manufacturing steps, like from the beginning, fiber, it comes with mineral, if we think about natural fiber. Also, it coming with other contamination from the machine and the other steps. So we use a sequestering agent to demineralize the water so that there is no calcium, magnesium, or any mineral in the water. The sequestering agent takes the mineral so that it does not interfere with the dyeing process. And we also use the non-ionic detergent to get the oil out from the fabric, which came from previous pre-processing of the fabric. Again, here in this case, we increase the temperature at 60 to 70 degrees centigrade temperature. This temperature is close to the glass transition temperature of the polyester fabric, and it emulsifies the oil. At this temperature, we get the emulsification of the oil. So we run the fabric, for instance, for this case, for 20 minutes, so that we can get rid of all the oil and impurities we have in the gray fabric. And we do this process one more time. So we drain after 20 minutes, we'll drain the fabric, we'll refill it at 60 degrees centigrade temperature again, we'll run it for a few times, 10 minutes, and we'll drain it again, and then we'll fill the fresh water for the next step. So these whole steps is called the pre-treatment. We are preparing the fabric for the dyeing. So these steps, after these steps, we'll go to the step which is called dyeing preparation, even again before putting the color into it. In the dyeing preparation, as from the previous steps, we have already pre-treated fabric at 60 degrees centigrade warm temperature. Then in the same water, we include two more agents, dispersing agent, because here in this case of polyester, the dye we can use is called dispersed dye. It doesn't bond easily with the polyester, so we want to disperse the dyes as fine as possible with the help of dispersing agent, and the leveling agent help us to for the even dyeing. And then we include the buffer solution to control the pH of the water. Then we try to run the fabric for a few minutes, here in this case 2-3 minutes, and then we check the pH until we keep adding the buffer solution until we get the pH in an acidic range less than 4.5. After we get the pH in an acidic range, we add color. For instance, here for this fabric, for example, I'm aiming for a yellow color. It was less attractive. I don't know why I picked that, but we can start with the yellow color. So we try to run the fabric in the similar temperature at 60 degrees centigrade temperature. So remember, we are dyeing a fabric which is polyester, which is very hydrophobic, and it doesn't bond directly with the dispersed dye. So you are trying to soften the polyester fabric. So you need to go at that glass transition temperature and more than that, actually. But we will do it very slowly so that there is no abrupt stress on the fiber. There is no quick degradation of the fiber. To take that into consideration, we try to start increasing the temperature very slowly. So for this case, I will start increasing temperature from 60 to 85 degrees centigrade at 2 degrees per minute. And then from 85, we're going to reach above the glass transition temperature, we'll reach at 105. So at 105 degrees centigrade, the polyester is almost softened, and we try to give a short hold on that temperature. And now this is the process of the dyeing. So we reach at above the glass transition temperature, where fiber make the space to take the dye inside them. So we go for this fiber, we go for 130, 35 degrees centigrade temperature, and we run for 30 to 45 minutes. So here I have two more notes about the shade. So you'll see if we use the same color, we have different shades as well. a light shade, dark shade, and it, depending on the buyer requirement or the requirement of my material, I will run it lesser or higher time. So for instance, if I consider a very light shade fabric, yellow fabric, I'll run it maybe for 30 minutes. And if it is, you want a very dark shade, I'll run it for 45 minutes or 50 minutes. And we usually, like in the industry, we usually closely work with the lab department. Whenever we go for a bulk production, the lab department does a bench scale test. So they usually inform us what would be the running time in the bulk scale for the desired shade. At 135 degrees centigrade temperature, the dyes are already inside the fiber. But now we need to close the fiber so that the dyes don't come out. So we start cooling down the temperature. So when we start cooling down the temperature, the polyester bond, again, the polyester comes into its original shape, and the dyes remain inside of the fiber itself. So we start bringing down the temperature. At first, we bring it down at 90, and then we bring it down at 60 degrees centigrade temperature. And then we check the shade. If we are satisfied with the shade we want, then we go for the reduction cleaning. So the reduction cleaning process is very important when you are talking about polyester fabric dyeing, actually, because as I said, the dyes we use for the polyester and elastane is dispersed dye. It's not chemically bonded. We physically insert the dye inside the polyester fiber. So there are some dyes which still remain on the surface of the fiber. So we want to get rid of this remaining residual dyes so that there is no question after we sell the product to the consumer. So for the reduction cleaning, we do 3 different steps. First, we use caustic soda and hydros to get rid of the surface dyeing. Then we do the washing at with the normal water without any detergent. And then we bring the fabric in an acidic range again, because with the caustic soda during the reduction process, we increase the pH level. And with the neutralization, we target for pH around 5.5. And with the neutralization, if we are satisfied, we drain out all the water, and the fabric is good to go for the drying process. This might be a lot of technical information, but I wanted to give this example for you to understand and to know how the dyeing process and what are the things we need to consider. As I mentioned during the description of the whole process, we use different auxiliaries, as you said, as you have noticed. We used different temperature. We consider how we are increasing the temperature and how we are decreasing the temperature. We consider how we are getting rid of the residual dyes or the chemicals we have. And I wanted to give this with a production scenario. Sure, thanks.
So how do you explain color fastness? What do you mean by so that it doesn't run? Does that depend on the type of fiber and also the length of time that when you
Yes.
do the dyeing?
Yes, that's a very good question. Thank you so much. For instance, if I come from the last step, if I do not do the reduction cleaning, then I will not have a very good color fastness. Because color fastness depends on the time you are selling the product to consumer and the way they are receiving and looking at the fading of the color. Without the reduction cleaning, after first or second wash, they will lose a lot of color. Then if I come back again with the, for instance, with the cooling down temperature. So here I cooled at 90 and 60 degrees centigrade. If I don't cool down the fabric in this rate, in this temperature, the polyester will remain open in the polymer scale, and we'll lose a lot of color as soon as they wash the fabric. Also, the final dyeing temperature was around 130. And this is very important. If I go for 160 degree temperature, I'll be destroying the fiber. The fiber will not remain. So also the time I'm running the fabric is also important. If I'm running this fabric for 1 hour at 130, I'll be destroying the fiber as well, because I'm keeping the fabric for a long time in a warm temperature. So yeah, a lot of things actually come into consideration, as you have mentioned, if you want to get a good color fast fabric.
So that applies to natural fabrics, because I've seen blends like in the past, they've done like in Europe, they've done like cotton with wool, and then sometimes cotton with polyester. And so for natural fibers like cotton and silk and cotton and wool, would that be different then, like the way that you? Okay.
Yeah, the consideration of temperature, the way the dyes will be also different. For example, the cotton I'll be using reactive dye. For silk, I'll be using acidic dye, or wool, I'll be using acidic dye, and other parameters will come into action. This is just to show an example of all the parameters we try to think about.
Thank you.
Yeah, excellent question. Thanks so much.
How do you bring the temperature of water up to 135? Was it done in some kind of pressure cooker?
Sorry, could you repeat the question again?
How do you bring the water temperature to 135?
Oh, it's the facility comes with the machine. In the machine, you have the capacity to heat up to this temperature. It's like an oven.
Yeah, but would the water evaporate at the temperature?
It's a closed machine. If you
So
see,
it's some kind of pressure cooker.
yeah,
type
also
thing?
pressure control as well. Yeah, but in the machine, we'll have from the beginning, for instance, 60 or 45. All the modern machine usually comes with the temperature capacity as well. The temperature we want to raise or bring down. Thank you so much. Okay, I'll move forward. I have 15 minutes or 10 to 15 minutes, let's say. Okay, okay, sounds good. Thank you so much. So we are dyeing the color. We are dyeing the fabric. We are dyeing our textiles. At the same time, we are dyeing our environment. This is an example I keep showing in all of my presentation, which is related with textile coloration. And these photos or the images was taken by me. It's nothing AI or nothing outside. It's very close. And this is very open environment. The one at the bottom is a river, and the other two is the storage channel, but open storage channel. And with all the coloration, as I said in the beginning, most of the cases is synthetic dyes. With all the coloration, we're dyeing the environment actually in a bad way. And if I talk about the textiles, it's in general, 20% of our global freshwater pollution is coming from textiles. And also, if I just consider a fabric in general, if you want to dye or color a fabric, for 1 kilogram of fabric coloration, it takes between 50 to 150 liters of water. And it's not about only the environment, it also affecting us. This is a very good review paper. You can have a look where they mentioned all the dyes or least chemicals which are responsible for human health deterioration. So, and it's not only based on the literature. In my study, I also wanted to see what kind of material, what kind of chemicals actually leaching from fabric. Not only about coloration, because as you have noticed in my previous part of the session, all the other chemicals are relevant as well, and all are synthetic chemicals, right? So we wanted to see what types of chemicals are leaching from some commercially available fabrics. So we studied 11 commercial fabrics which are made from different combination of high performance fiber, which had particularly dyed and water repellent finish for its intended end use. So we did a very in-depth study. We took the water, leached water from the fabric. Then we analyzed the leached water with 2-channel gas chromatography with TOF-MS and also with FID. And we figured out 276 chemicals, unique compound. We identified 276 unique compounds from this 11 fabric in combination. And based on our threshold with the available database, we found 70 compounds which are relevant with the textile production. But not all 70 compounds are bad, right? But here, the example of few chemicals which can I explain a little bit. For instance, some of the chemicals is we found as a degradation byproduct. For instance, the long chain carboxylic acid or the degradation byproduct of the diamine, this came due to the degradation of the fabric. So if we come to the dyes and pigments, we got some of the chemicals which is related with the azodyes, and we got some surface finish product. It was very expected that we get some water repellent surface finish chemicals, so we found that. So actually, not about only literature, and with my studies as well, and I studied completely different category of fabric than what usually we find in the literature, and the result is quite similar. We are getting a lot of chemicals leaching out from the fabric. So the sustainability is one of the path forward. It could be natural dyes and pigments using, as I showed in my preliminary example. And there is some water efficient dyeing process as well. The one example I'm showing here is a supercritical carbon dioxide dyeing with the high pressure and the temperature. The carbon dioxide goes above a critical point, and with that critical point, we try to disperse the dye inside the fiber material. However, this is also there are some other dyeing process, air dyeing, plasma assisted foam, and ultrasonic. In all of the cases, the water for instance, for supercritical carbon dioxide dyeing, you don't need to use any water, and 95% of this supercritical carbon dioxide you can reuse or recover from the chamber. Also, the water recycling process using effluent treatment plant, effective effluent treatment plant, also using chemicals which discharge no hazardous compound or tend to no hazardous compound. So these are path forward for sustainable application. And in my research, I also did some research with the sustainable dyeing process. So again, if I want to come to my lecture in the beginning, before the dyeing, we need a pre-preparation, which we call discovering and bleaching, to get rid of the oil and impurities in our gray fabric. Maybe some of you know soap nut. Soap nut is a naturally abundant material. It has some surfactant properties. So we wanted to see if soap nut can be an alternative of synthetic surfactant. So we tried different concentration of soap nut up to from 1, 3, 5, and up to 10%. And we characterize the performance by weight changes, by absorbency, because if I consider the next step as dyeing, absorbency is important. We characterize the strength of the material after this processing, and also we try to compare the cost consumption. So the major finding is that with the 10% soap nut concentration, we didn't find a better performance. The performance was comparable in all of the categories I mentioned in above. However, another promising sector as a path forward is implementing structural color without using any dyes or pigments, or if we use the structure of the material more than the dyes. So the color of an object is not determined by pigments or dyes while we talk about the structural color. And this is some example. I'm not going to describe all. This is some example of structural dyeing, structural coloration, and people already started using. The industry application is not as moving fast as it did for synthetic dyeing, but I did some research in my previous lab as well. With changing the structure, we can really see the color changes, but the durability and coming it to a bulky scale is still challenging for the researcher. So moving forward, we have still 5 to 10 minutes if you have any questions. We have a question here.
Could you see an image of that, like the last slide you just showed, the physical structural properties?
Yes.
Do you have an image of the resulting fabric?
Resulting fabric. So in the fabric people are using in the lab scale actually. In the bulky scale, they're using the structure as well as different kinds of dyes and pigments as well. So it's not 100% sustainable. That's why I was mentioning. Like they're trying to use the structure of the material and as well as the structure of the dyes and pigments as well. But in this, this is a review article. They did not mention very strong result that I could show. Yeah, but there is a lot of challenge remaining because this structure easy to prepare on a polymer scale, but it's hard to do in a fabric scale.
Right. I'm going to hog the mic for a second because I'm fascinated by this last part, and I feel like you just sort of skipped over this part. Could we back up one more slide? Yes. When you say comparable performance, do you mean that the cost comparison was also comparable?
The cost was low because for sourcing this material, nobody used this material. This is like wastes.
Oh, no, I have it.
Oh, you have it. Okay, nice. So in that case, the cost was low. And regarding the other performance, like weight changes, absorbency, and strength, the value was similar.
Right. So it costs less and it has comparable performance. And then what about water consumption? Is it the same amount?
Same. So we just changed the detergent and used the same liquid ratio.
I swear this is the last one. You guys can have the mic. And this was tested on synthetic materials?
No, this was tested on cotton fabric.
Okay. So the side-by-side comparison was between synthetic detergent on cotton and natural detergent.
Yeah.
Okay.
Yeah. And I can send you the paper if you're interested after this. Yeah, sure. Thanks. Excellent question. Okay. Let's talk about some functional finishes. I started this session talking about UV effect of light. So I wanted to show an example of effect of light on fabric on fiber. So this study we published in 2024. Yeah, we published in 2024. So we studied different fabric in total. Here in this study, you can see the result of 3 fabric, but we studied 5 and 3, 8. In total, we studied 8 fabric. We exposed the fabric to artificial light, the fluorescent light, in different UV irradiances. And you notice that, for example, here, as you see, after exposing the fabric for 240 hours, we saw cracks on the fiber. That was not visible on the surface, but in the micro scale, there was fibers. And then we evaluated the strength. We evaluated other properties like chemical degradation or notice of chemical degradation with the XRD, with the FTIR as well. But here I'm showing the example of strength loss with the different temperature and irradiance. The idea for here to show that the fabrics really, and this study is based on the high performance fibers, which is way more strong than the conventional fiber we are using. The finding is that we found that with the light, the fabrics degrade very quickly. It has the morphological changes, it has the chemical changes. So we wanted to figure out what could be the solution. So we developed some UV protective solution. For instance, here the fabric you see, which is, this is a fire protective fabric, so we did some burning test as well. The fabric you see, we did some burning test, and this is the fabric after the finishes. For this research, we didn't publish any article yet because the industry worked. They wanted to patent the product, so we're still waiting. So here also, that's why you don't have that much information about what are the chemicals we used. But we found this is the data point after exposing to UV is the fabric without any UV finish, like without our UV finish. And this was gray fabric. And after we included our UV finish, we found a significant improvement even after 96 hours of aging and 256 hours of aging as well. Talking about the functional finish, another functional finish is the mosquito repellent. Here in Canada, we might not have that much problem, but if you are going for camping frequently during the summer, I guess you have experienced the what mosquito can do. So yearly, more than 1 million people experience death with the mosquito, and there are a lot of synthetic solution. However, based on the literature, this causes skin burning, itching, tingling. So we wanted to get some inspiration from nature and wanted to see if some natural extract can be helpful to develop some mosquito repellent finish. I'm going very fast here because we are running out of time, but we used peppermint and garlic extract together. In the literature, before people used peppermint alone, so we wanted to see how the combination with the garlic. We used a tiny percentage of garlic. We prepared 4 different samples with different concentration, up to 35% concentration of the of our extract, which is combination of peppermint and garlic. We did 2 tests. One is WHO standard cone test, and another is I'll explain the test later. So for the cone test, the result we found around 13.33% of the mortality rate after 60 minutes. And after 24 hours, we found up to 76.6.7% mortality rate of the mosquito. So the way we do it in the inclined area, we put our samples, and then in the cone, we keep the cone, and then we insert, here for our case, we inserted 24 mosquito, and then we cover the area which we use to insert our mosquito. And we keep the mosquito in that cone with the expose of sample fabric. For our case, we kept it for 60 minutes. We counted, and then we did another test with the 24 hours. And we got, as I said, with 35% extract solution, we got the result of 76.67% mortality. We did another test. The result is also quite similar. The highest mortality rate we found around 85%. Here is a modified cage test, but similar. We used the fabric on the walls, on our sample fabric on the walls of the cage. Also, we had some control fabric without the finish as well. So I'm moving to the conclusion, just respecting the time we have. If we want to move with the sustainable solution, the renewable resources could be a part. However, as you can see in this picture, we have to compromise some quality, like fastness, the affinity, the shade uniformity, and the reproducibility is also a concern. Also, scale. Some of the things we did, also other people are doing in the lab scale, and there is a long way to go to take things into the market with the scale up and the facility we have. At the end, I'll just say that the environmental responsible dyeing and finishing method may compromise some durability properties, some quality, some aesthetic properties, yet this significantly reduce production, energy use, and the chemical load. With that note, I would like to thank all of you for being here. Again, I really appreciate that you took the time, even the weather was not in our favor. Thank you so much.
Hi. I have a question for you.
Sure.
I don't know, I saw a documentary not that long ago, and Colombia is releasing mosquitoes infected with a naturally occurring Wombalgia bacteria because they're trying to fight diseases like dengue and Zika and other diseases. What is your thought on that? Because there were also other scientists that said, it's not really working that well, but they are releasing. I mean, they've got labs, and it's scary.
Yeah. That's a very good question. I don't know about the news you said about the Colombian, what type of chemicals they are used. But if I take the question and answer in a positive way, for instance, if I cite our research, the things we use is natural. So you don't have the problem of the skin problem or anything if you're worrying that. But as I said in my last slide, while we are using the sustainable thing, we might need to compromise, and that's happened with our research as well. After 15 wash, we didn't get that much performance compared to a synthetic material will give you. So still, I guess all the people, including us, is working on that. But yeah, thanks so much for the question.
Any other questions before we come to a close? Oh,
Hello, I just wanted to ask why when the fabric was why was it on an angle against the support wall? Like, what was the purpose of that?
Oh, that's a very good question. And to be honest, I don't have the answer. So this is the standard of WHO. So usually in most of the cases, whatever textile testing we do, we try to follow a standard so that this test is reproducible across the world, right? But I did not investigate that much what's the purpose for the inclined, but that's a very good question. Maybe I'll try to have a look on my own. But yeah, that's a very good question.
I was also wondering, from the perspective of testing out for the mosquitoes, your testing out was in the conditions where the mosquitoes are exposed to that fabric for a long time. But what are the outcomes of this research for the perspective of the fabric use? Like, if we are putting the element on the fabric for people that are, let's say, going for camping or walking around, is that anyhow protecting them from being bitten, because the mosquito is not then interested in the scents, because the fact of killing a mosquito was in the lab. I don't particularly understand how is that can be further translated into protecting gear.
Yeah, no, thanks so much. That's an excellent question. And that's the aim. Like the research we did in a fabric scale, not in a garments scale, but we believe that if someone is wearing that fabric, because of the smell also as well for the fabric itself, after the peppermint and garlic extraction dyeing, we did it in a dyeing process. Dyeing, it should be helpful to keep ourselves more protective from mosquito if you're using it like during camping. Yeah, that was the aim. Yeah. Thanks so much for the question.
Hi again. So hospitals use, well, I mean, when I think about colored-based or colored fabrics in hospitals, it's mainly, I'm thinking of scrubs, and those, I believe, are always synthetic materials, correct?
Yeah.
What do you, like, do you see it possible for hospitals to move away from synthetic materials towards natural fibers dyed in natural ways, or using, soap nets and what have you, in the context of color, which I find is such an interesting way of entering the conversation, because scrubs, I mean, they're color-coded for what position or role you're in, and then they kind of, I think that high contrastness is part of why they're used, or what's become important to people, because if you get blood all over it, it washes out from the synthetic fiber, et cetera, et cetera. So I'm so curious, do you think it's possible, and like, should we? How do we move that way?
Yeah, thanks so much. And this is a very timely question. Thanks again. I strongly believe that's possible. And I saw some articles who started producing these gowns or scarf from non-woven, but using the synthetic fiber as well. I don't know how many hospitals adopted these technologies, but I know some of the people are working to explain this technology so that it goes to the consumer and knows that what is available and not. But I strongly believe that's possible. And if I talk about the color, and if I go to my slide where I showed natural color types, or where is it? If you see the natural color types and different dyed fabric are presented here, in most of the cases, these are in light shade. And I see in some of the cases with the scarf, this shade goes, right? There might be not the same exactly shade which are in the market already, but I see a good potential, and I strongly believe that's possible to move forward. Yeah, thanks so much. That's a very timely question.
Do we have any other questions? Great. Well, thank you for being such a interested audience in this subject. We really appreciate it. And our next talk is next month, February the 25th. That's open for registration now, so you can join our final talk in this series. So thank you again for coming, and please stay afterwards and introduce yourselves to each other. And hopefully we'll see you again next month. Thank you.